Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using quotient rule for derivatives. So as per the problem, determine dy over dx at the given value of x. So we have to find the derivative of these two functions. So let's start with the first one. So y equals 3x plus 2 over x plus 5, and we have to find the dy over dx at x equals -3. So we'll use the Leibniz notation for the derivative, and we'll use the product rule, the quotient rule. So dy over dx equals, so as per the quotient rule, so we start with the derivative of the numerator, which will be 3 plus 0 times the denominator, which is x plus 5, then minus the numerator expression, which is 3x plus 2, times the derivative of the denominator, and the denominator is x plus 5, so the derivative will be 1 plus 0 over the square of the denominator, which is x plus 5 square. Now we have to find the derivative at x equals -3. So we should sub in x equals -3 in this step. We don't have to simplify it first and then sub in x equals -3. So that will save us some time and steps. So dy by dx equals, so the first parenthesis is just 3, and in the second one we do -3 plus 5. So we are subbing in x as -3 minus then 3 times -3 plus 2, and 1 plus 0 is just 1 over, and now we have to do -3 plus 5 square. Now we can simplify it further. So dy over dx, so in the numerator, so in the second parentheses, -3 plus 5 is equal to 2. So we get 3 times 2, and then minus, and in the other parentheses we do 3 times -3, which is -9 plus 2. Now we don't need to write the 1 because multiplication by 1 doesn't change anything, and in the denominator we get 2 square. Now we can simplify it further. So dy over dx equals, so 3 times 2 is 6 minus -7 over 4. So -9 plus 2 is equal to -7. And now we can simplify it further. So dy over dx equals, so 6 minus -7 is equal to 13. So we get 13 over 4. So this should be the final answer for dy over dx for the given function at x equals -3. Now we can find the derivative of this second function, which is also a rational function. So we'll have to use the quotient rule. So we'll start with the dy over dx equals, so we'll use the quotient rule. So we start with the derivative of the numerator expression, which is 3x squared times the denominator x squared plus 9 minus the numerator expression x cubed times the derivative of the denominator, which is 2x plus 0 over the square of the denominator. Now we have to find the dy over dx value at x equals 1. So we should sub in x equals 1 in this expression. We do not have to simplify it first before we sub in the x as 1. So we get 3 times 1 square times 1 square plus 9, then minus 1 cube times 2 times 1. So we can get rid of the 0 because addition by 0 doesn't change anything. And in the denominator, we get 1 squared plus 9 parentheses and then squared. Now we can simplify this expression. So dy over dx equals, so 3 times 1 square is 1. So 3 times 1 is just 3. Parentheses, so 1 square is 1. So 1 plus 9, which is 10. Minus, now 1 cube is 1. And 1 times 2 times 1 is just 2. Over, now 1 square is 1 and 1 plus 9 is 10. So 10 squared. Now we can simplify the numerator further. So dy over dx equals, so we get 30 minus 2 over 100. Now we can simplify the numerator further. So dy over dx equals 28 over 100, which can be reduced to 7 over 25. So this should be the final answer for the value of dy over dx for the second function at x equals 1. So these are the steps you have to keep in mind to solve a problem like this one. So the first step is to use the quotient rule to get the expression for dy over dx, and then we sub in x as the given value to find the value of dy over dx. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.